In this video, we're going to look at ATP synthase, which acts as an enzyme to generate, as you can probably guess from the name, ATP. Now, ATP synthase has two parts. One part that's situated in the membrane, called F0, and another part that's situated out of the membrane, called F1. Now, both these independently can act as rotors, but we'll see how they're linked together in a second. We'll start with the things in the membrane. In the membrane, we have what's called the C subunits. Now, there's actually about 8 to 15, depending on the species, or actually depending on the ATP synthase. So there's about 8 to 15 C subunits. We'll go into their function later. Next to that is something called the A subunit. This has I'll do this in green. So this has two proton half channels embedded within it, which I'm going to draw like that. Okay, so that is basically F0. There's some other stuff, so we actually have some part of the epithelial stalk, which I'll explain the function of in a second, but that there is everything in F0. So this can independently kind of act like a rotor, and that occurs due to a proton motive force. So protons traveling through this A subunit, they are then attached to the C subunit, which then does a full rotation, well, almost full rotation, with the protons attached, and then they leave through the other half channel. This is called the turnstile mechanism of a motor, and it's kind of like an electrostatic attraction along with diffusion that's causing the rotation of this C subunit. We don't know a lot about this F0 because it's a membrane-bound protein. We can't really get much more detail on it, or get a lot of detail on it rather. In comparison, the F1 subunit, we have a lot more information. The most prominent part, or the really only part of the F1 subunit that rotates is something called the gamma subunit. Let's draw that in here. So this is the gamma subunit. I should also note that C rotates while A and B2 don't. So this is gamma subunit, and that rotates within F1 ATP synthase. There's also an epsilon subunit there, which I'm going to explain the function of in a second. Attached to the end of the gamma subunit, actually let me rephrase that because it's not attached, but at the end of the gamma subunit, trying to find a different color pen, which I can't. Oh, found it. It's under my foot. So at the end we have 6 other subunits. Let's try and draw these symmetrically. Something like that. Okay, and this acts like I don't know what it looks like, but it looks like something. We have beta, alpha, beta, alpha, beta. I've missed one. That's a subunit there. Alpha, beta, alpha, like that. Okay, so this is actually where ATP synthesis happens. This beta subunit contains the catalytic site for ATP synthase. The alpha subunit doesn't really have that sort of catalytic role. It's there for more regulatory roles, but it does form hydrogen bonds. I adjust my pen lid. It does form hydrogen bonds with the ATP, and it kind of makes the whole enzyme more efficient. Now, we actually almost have a complete picture. We're just missing one subunit from our picture, and that is that of delta. So delta's up here, and that shouldn't really be attached there. So delta basically attaches this beta alpha subunit to this B2 subunit and holds everything in place. This does not rotate. This rotates. So this gamma rotates, this epsilon rotates. Alpha and beta don't rotate. They allow the gamma to rotate within it, and they're attached to the membrane by this B2 and delta subunit. And this epsilon subunit, basically, it helps bind this gamma subunit to the C subunit, but it also has roles in conformal chain changes of the ATP synthase, and also has inhibitionary effects on the enzyme. So there's one last thing I want to show you, and that's the top-down view of this subunit here, of this actually viewpoint here. So let's call it beta, alpha, beta. Write that out, we don't need it. Alpha, beta, alpha, Now that gamma subunit in the end, that's antisymmetric, and that rotates around in 40 and 80 degree steps. Now those 40 and 80 degree steps are coupled to chemical reactions within this alpha beta subunit. I'm not going to go into detail into that in this video. So that's basically the structure of ATP synthase. I'm just going to quickly go over the roles of everything just once more. You can stop the video now if you want, but let's just quickly run over the role of everything in case I missed anything that I needed to say, or anything that was of importance. So this perfilial stalk consists of the beta 2 and the delta subunits that helps hold alpha and beta, holds the alpha and beta stationary basically, and holds it to the membrane, stops it floating off. This gamma epsilon subunit binds the epsilon to the C. It also has roles in the conformal change of the ATP synthase and has inhibitory effects on the activity of the enzyme. The gamma subunit here is rotated, caused by either the C subunit or, in fact, in ATP hydrolysis, which I'm not going to go into, it can be caused by the rotation of this up here. Now that causes if it is being driven by C, it will cause these conformal changes within these alpha and delta subunits, and that's what causes the enzyme activity to go on. It actually moves these through a series of cycles called loose, tight, and open configurations. The alpha subunit doesn't seem to have a catalytic role. It does have regulatory roles and increasing efficiency of ATP synthase, of the efficiency of the enzyme as a whole, basically. It's the delta sites that hold the catalytic sites and basically are where the synthesis and hydrolysis of ATP occurs. The C is the driving force of the rotation in normal ATP synthesis. They can accept protons from the proton half channel, which then go under a series of rotations, and which causes the proton to be released through the upper half channels. The A subunit provides attachment for the B2 and contains the proton half channels, and finally the proton half channels deliver the protons to the C subunits, allowing them to rotate. Okay, so that's the end of my video. References, etc. are on my website, which I'm going to link to in the description below. And thank you for watching.